Carbon is the superstar of chemistry. It's diamond and pencil lead, the fuel in your stove, the plastic in your phone, and every living thing on Earth. One element, millions of compounds. In this chapter, we'll find out why. How carbon bonds, the hydrocarbons it builds, the functional groups that give them character, and the chemistry of ethanol, ethanoic acid, and soap, from scratch. Carbon has 4 electrons in its outer shell, and it needs 8 to be stable. Rather than lose or gain 4, it shares electrons. That's a covalent bond. Because it makes 4 bonds, carbon is tetravalent. Sharing also means covalent compounds have low melting points and don't conduct electricity since there are no free ions. Why so many carbon compounds? 2 reasons. Catenation. Carbon atoms link to other carbon atoms in long chains, branches, and rings. And tetravalency. Each carbon can hold 4 other atoms. Together they build endless stable molecules. Pure carbon even comes in different forms called allotropes. Diamond, where each carbon bonds to 4 others in a rigid 3D network, the hardest natural substance. Graphite, flat sheets that slide and conduct electricity. And football-shaped fullerenes. Compounds of just carbon and hydrogen are hydrocarbons. If every carbon-carbon bond is a single bond, the hydrocarbon is saturated. These are the alkenes, like methane and ethane. If there's a double bond, it's an alkene, and a triple bond makes an alkyne, both unsaturated. Carbon skeletons can be straight chains, branched chains, or closed rings. Organic compounds fall into families called homologous series. In a series, every member has the same general formula and the same functional group, and each differs from the next by a CH2 unit. They share similar chemical properties, while physical properties like boiling point change gradually as the chain grows. The alkanes, methane, ethane, propane, butane, are one such series. What gives a compound its character is its functional group, a special atom or group that decides its reactions. The main ones for class 10 are the halogens, chlorine or bromine, the alcohol group, OH, the aldehyde group, CHO, the ketone group, a carbon double bonded to oxygen, and the carboxylic acid group, COOH. The functional group is shown by a prefix or a suffix in the name. 2 more ideas. Isomers are compounds with the same molecular formula but different structures. Butane, C4H10, exists as a straight chain and a branched chain. And naming, take a root for the number of carbons, meth, eth, prop, but, add a suffix for single, double, or triple bonds, ane, ene, or yn, then mark the functional group with its own prefix or suffix. Now, how carbon compounds react. Combustion. They burn in air to give carbon dioxide, water, and heat. Saturated ones with a clean blue flame, unsaturated ones with a sooty yellow flame. Oxidation. Alcohols can be oxidized to acids. Addition. An unsaturated compound adds hydrogen across its double bond over a nickel catalyst. That's how oils are hardened into vanaspati G. And substitution. In sunlight, an alkane swaps a hydrogen for a chlorine atom. 2 important compounds. First, ethanol, common alcohol, a liquid used in drinks as a fuel and as a solvent. It reacts with sodium metal to release hydrogen. Heated with concentrated sulfuric acid, it loses water and becomes ethene. Useful as it is, ethanol in drinks is a depressant and harmful in excess. Second, ethanoic acid, acetic acid, the sour part of vinegar, which is a 5 to 8% solution. It's a weak acid. It reacts with a base to give a salt and water, with a carbonate to fizz out carbon dioxide, and with ethanol to make a sweet-smelling ester. Finally, soaps are sodium salts of long-chain fatty acids. Each soap molecule has a water-loving head and an oil-loving tail. In water, the tails trap grease and the molecules cluster into balls called micelles that wash the dirt away. In hard water, soaps fail, so we use detergents instead. Quick check. The question's on screen. Pause if you like, but try it first. 10 seconds, go. Carbon has 4 electrons in its outer shell and forms 4 covalent bonds. It is tetravalent, so its valency is 4, option D. And that's the chapter. Carbon shares electrons in covalent bonds and is tetravalent. Catenation and tetravalency give millions of compounds and allotropes. Hydrocarbons are saturated or unsaturated. Functional groups and homologous series organize them. And carbon compounds burn, oxidize, add, and substitute, as seen in ethanol, ethanoic acid, and soaps. That completes Class 10 chemistry on Clarix. Free notes with 60 practice questions are in the description. Subscribe and keep going.